This video will demonstrate calculation of changes in productivity using the example of problem 110 in the textbook. In this problem, we have data on three inputs: labor, capital investment, and energy, as well as data on the outputs. And this data is for both last year and the current year. The manager has invested $3,000 in additional capital and wants to see how this has affected the productivity of the bakery, especially in terms of energy. There are several calculations we can use to try to gauge the effectiveness of the capital investment. First of all, we can calculate the single factor productivity for each year for these three inputs. To do this, we can take the output or production and divide this by each of the input. I'm going to put a dollar sign or absolute reference in front of row 2 because I want to divide the output by each of the measurements, each of the inputs. So the labor productivity in dozens per hour was 4.29 for last year. Because we have the absolute reference on row 2, we can simply copy this formula down to the other two inputs. Additionally, because we have the absolute reference on row 2, but there are no absolute references on the columns, we can copy these three formulas over to our current productivity. Notice that this now references column C, the data for this year. The productivity measurements are in dozens per hour, dozens per capital dollar, and dozens per BTU of energy. The percent change in productivity will show if there has been any improvement in any of the productivity for the three inputs. Change in productivity is measured as the current productivity minus the previous productivity, all in parentheses, divided by the prior year or prior period productivity. I'll reformat this number in Excel to be a percent change rounded to 2 decimal places. Because there are no absolute references in this formula can be copied down to the other two inputs. What we see is that productivity has improved by about 7.7% for labor. Productivity has improved in terms of energy by about 9.1%. We would certainly believe that the percent change in productivity for energy could be potentially attributed to the additional capital investment. Now, we see that the productivity of the capital investment certainly has decreased, and that is largely due to the increase in capital. This doesn't necessarily mean the increase in capital was a bad decision, because potentially they could benefit from this capital investment for several years to come. And those type of considerations should have been factored in when the investment was made. We might also want to calculate multi-factor productivity measurements. We need additional information other than what's given in the textbook to calculate multi-factor productivity measurements. So we're going to make some assumptions here. We'll make the assumption that labor is $10 per hour, and energy costs 50 cents per BTU. In this way, we can calculate the input dollars for each period. The input dollars are the units of each input used times the cost of that input. So for instance, for labor, input dollars would include 350 times 10, if we're making the assumption that labor is $10 per hour. Capital investment is already stated in dollars, so we'll simply add in the amount of the capital investment. And then for energy, we're making the assumption that energy is 50 cents per BTU. So we'll multiply the BTUs used times 50 cents. Of course, if the costs change year to year, we would factor that in as well. Here we're going to make the assumption that the unit costs per hour and per BTU are the same for each year. Now, multi-factor productivity then is the production, or amount produced, divided by the input dollars. So it will be production divided by the input dollars that we calculated in the previous step. We can see that multi-factor productivity, when we consider all of these inputs, is decreased. And the percent change is the new productivity minus the old productivity divided by the prior productivity. We'll reformat this number in Excel as a decimal number with 2 decimal places and a percentage sign. So multi-factor productivity is decreased by 11.6%. This may be a little bit of an unfair measurement because obviously a large amount of this change is attributed to the capital, and the capital may continue to benefit the bakery for some time to come. We might want to adjust our multi-factor productivity measurement to include just the labor and energy. Let's recalculate the input dollars with just 2 inputs, labor and energy. So input dollars would be 350 times 10 plus 3,000 times 50 cents. If we just consider the 2 inputs, the multi-factor productivity would be the output or production in dozens divided by the input dollars. We'll copy this formula to the current year. We can see that if we just consider the 2 inputs, then multi-factor productivity has increased. The percent change is the current number minus the previous productivity divided by the prior productivity. We'll format this number as a percentage with 2 decimal places. Two things have happened at the firm since the capital investment. Energy use has gone down, so we have seen some increase in efficiency in terms of energy due to the capital investment, but labor productivity has improved as well. It's hard to tell whether this could be attributed to the increase in capital investment or the new oven, but we may want to investigate this. In any case, this last measurement that we've made, an adjusted multi-factor productivity, might be the best indicator of whether or not the capital investment is making a difference in the efficiency of the bakery.